Okay. From the last lesson, I'd made mention about the aspect of identifying a number that can be a divisor to a given number, which I'll simplify by just saying we'll look at the test of divisibility. When you're given a number, no matter how large it may be, you should be in a position of probably finding a way of reducing that number or finding a suitable number that can be a divisor or can go into that given number. And that is exactly what the test of divisibility is all about. So, for today, I'll start. All numbers, this is the first point. All numbers with an even end digit are divisible by 2. I think this is a point that I'd even made mention in our last lesson. And what we are saying is, if you look at the set of even numbers, it is basically starting from 0, 2, 4, 6, 8, and many more other numbers that can be part of this set of even numbers. So if the end digit is any of what is in the set of even numbers, then you know they are divisible by 2. Now, for argument's sake, let's pick a number. I'll say 482. The minute you see the 2, you know that this 482 is divisible by 2. Let me pick another number. Let's say 534. It may look like it's not divisible by 2, but the end digit qualifies it to be divisible by 2. Now, to help us understand what we're talking about, we'll go to long division. And we're dividing by 2. 2 into 4, that is 2. 2 times 2, that is 4. 4 from 4 is 0. We drop 8. 2 into 8 is 4. 4 times 2 is 8. 8 from 8 is 0. We drop 2. 2 into 2 is 1. 1 times 2 is 2. And 2 from 2 is 0. This justifies or makes a point to say that this concept is actually true. Then let's move to the next number and see if it will give us the same result. Now, for the sake of space, let me try and create a bit of space. We said 534. 2 into 5 is 2. 2 times 2 is 4. 4 from 5 is 1. We drop 3, we have 13. 2 into 13 is 6. 2 times 6 is 12. 12 from 13 is 1. We drop 4. We have 14. 2 into 14 is 7. 7 times 2 is 14. 14 from 14 is 0. So we'll have found our result. So this justifies the first point. Now we look at the second point of divisibility, and we'll look at the number 3. We're going to look at numbers that are divisible by 3. Then from there, we'll start like this. If I may go through that statement again. A number is divisible by 3 if the sum of its digits is divisible by 3. What are we saying here? Let's say, for example, you're given a number like, let's say, e.g. 411. When you look at 411, it will be quite difficult for you to figure out what number can be a divisor to this given number or a factor to this number. Now, mathematics being what it is, we have these interesting points. Once you know about them, it will be easy for you to figure out what number. So we are saying a number is divisible by 3 if the sum of its digits is divisible by what? 3. So when you look at our number, we have 4 plus 1 plus 1. And our result is what? 6. And when you look at the number 6, 6 is divisible by 3. And once you discover that the number that you get as the result is divisible by 3, then it simply tells you that the number 411 is divisible by 3. And that is the trick. Now, we go and try this using our long division. We have 3 here. 3 into 4 is 1. 1 times 3 is 3. 3 from 4 is 1. Then we drop the 1. We get 11. 3 into 11 is 3. 3 times 3 is 9. 3 from 11 is 2. 9 from 11 is 2. Then we drop the 1. We get what? 21. 3 into 21 is 7. 7 times 3 is 21. 21 from 21 is 0. So this actually proves to say that this, I don't know if I'm supposed to call it a principle or a theory, does work. But anyway, for argument's sake, let's pick another set of numbers, or let's pick another number, then try out if it will equally work out the way we think it will work out. So if I were given a class, I would have asked anyone from the class to give us a number that when after you add, the result is divisible by 3. So since I don't have a class, so I would basically think of numbers such that when I add them, and if they give me a result that is divisible by 3, then we'll know that this particular rule does work. So I'll wrap this off for now so that we look at the second set of numbers. So we're saying 372. Okay. When we add 3 plus 7, that is 10. 10 plus 2 is 12. Now let's find out if this works. Firstly, this number is divisible by 2. So let's find out. 3 plus 7 is 10 plus 2 is 12, and 12 is divisible by 3. Huh? Okay, now let's see if this will work. 3 into 3 is 1. 3 times 1 is 3. 3 from 3 is 0. We drop 7. 3 into 7 is 2. 2 times 3 is 6. 6 from 7 is 1. We drop 2. We get 12. 3 into 12 is 4. 4 times 3 is 12. 12 from 12 is 0. The rule does work. Okay, we proceed. This was just for numbers that are divisible by 3, that is. So we are going to look at our next number, where we're going to look at numbers that are divisible by 5. A number is divisible by 5 if the end digits are 5 and 0. So similar to numbers divisible by 2, by just looking at the end digit, it's possible to tell that this number is divisible by 5. So this is among the simplest possible rules that are easy to master. I can start with the number 25. 25, the end digit is 5, then automatically we know this is divisible by 5 because 5 into 25 is 5. Then normally we look at bigger numbers. I'll say, let's say a given 230. 230 is divisible by 5 because the end digit is what? 0. And the same 230 is divisible by 2 because the end digit is what? Even. So with this one we'll say 5 into 23 is 4. 4 times 5 is 20. 20 from 23 is 3, then we drop the 0, then 5 into 30 is 6. 6 times 5 is 30, 30 from 30 is 0. Now, hypothetically speaking, what about if we're given a number like 545? Again, the same rule applies. For as long as the end digit is 5, then you know this number is divisible by 5. So we'll start like this. 5 into 5 is 1. 1 times 5 is 5. 5 from 5 is 0. We drop 4. 5 into 4 is 0. That is 0. Then 0 from 4, that is 4. Then we drop what? 5. 5 into 45 is 9. 9 times 5 is 45. 45 from 45 is 0. So this again proves that this particular rule does work, and these are the results. So when you follow these rules, it will make your calculations a bit easier and faster when you're dealing with division, because you know the best number to use. Now let's look at another number that is of interest. We'll look at the number 9. We'll look at the number 9 and numbers that are divisible by 9. By 9. This one is similar to the rule where numbers are divisible by 3. Using the same basic concept, it's all about adding the digits, then the sum you get if it is divisible by 9, then you know that given number is divisible by 9. For example, 756. 756. So what are we saying here? We are saying 7 plus 5 plus 6. 7 plus 5 is what? 12. 12 plus 6 is equal to what? 18. 18 is divisible by 9. So for the fact that the sum of the digits and the result is divisible by 9, it simply tells us that 756 is actually equally divisible by 9. Now, interesting as it may be, there is the issue of knowing and understanding the multiplication table, and that's where most of pupils that pass from grade 7 to 8 and move on to write the grade 9 exam have problems, because they don't really know the multiplication table. Now, there are things that will help you. I'll give you an example. We are looking at the number 75. 75, the next number that is a whole number is either 70 or 80 if you're counting in tens. So, for you to get 70, it is 7 times 10, and your result is 70. And if you remember in our earlier lesson, I said multiplication is basically repeated addition. So, if we are going to say 7 times 9, 7 times 9, it is simply subtracting 7 from 70 is what will give us that result. And the result will be, if we remove 7 from there, we're going to have 60 what? 3. Now, we are dealing with 75. 75, the next number was what? 80. How do you get 80? You get 80 by saying 8 times 10, and your result is 80. So the number before 10 is 9. And the number you're subtracting is what? 8. Okay? Since the number you're subtracting is 8, because we're dealing with repeated addition, you will know you'll be subtracting 8 from 80. And your result will be what? 72. So already here, it will be easy for you to find a number that 9, the result when you divide 9 divided into 75. Already we know the result should be what? 8. So we'll say 9 into 75 is 8. 8 times 9 is 72. Then 2 from 5 is 3. Okay? Then we move on to this one. We drop the 6 and we're going to have what? 36. Using a similar concept, the next number that is above 36, that is a multiple of 10, is 40. So we are going to say 4 times 10 is equal to 40. So the next number before 10 is definitely 9. So 4 times 9 is definitely going to be 40. We subtract what? 4. And the result is what? 36. So 9 into 36, the result is 4. 4 times 9, your answer is 36. And 36 from 36 is 0. I hope this is just additional information, but the concept is basically based on this and the adding of the digits. But this is just additional information, just in case you meet a number, then you don't know the number that you can use as a divisor. Okay, let's try another example. Can we think of any number that is divisible by, okay, for argument's sake, let's pick a number. I'll say 2, 3, this will give me 5, then I'll put 4. Then from there, 2 plus 3 plus 4, 2 plus 3 is 5, 5 plus 4 is equal to what? 9. So automatically this tells me this number is divisible by 2 and 9. 9 into 23. The answer is 2. 2 times 9 is 18. 18 from 23 is 5. We drop what? 4. Then we have 54. The next number to 54 that is a factor of 10, that is a multiple of 10, is 60. So we'll say 6 times 10 is equal to 60. So 6 times 9 is definitely 6 from what? From 60, and that will give us what? 54. So we know the number 6 goes into 54 6 times. 6 times 9 is 54. 54 from 54 is 0. So that basically answers our question. And this ends our lesson on the test of divisibility. And this is just additional information for you to use as you do your work. No particular exercise is needed for this particular work. We'll move on and look at what we intended to look at today, and we are going to look at the lowest common multiple. Now, when you're talking about the lowest common multiple, this is where you get to see much of the application of the work that we have done in this particular part of our lesson.